going on here with your parabolas. We're going to start with a real simple one. We have the sum of two numbers. We're going to find two positive real numbers that satisfy this requirement. Two positive numbers. Their sum is going to be 110, and their product is going to be a maximum. So stay with me. So we are going to let x equal the first number, and let y, guys, equal the second number. We need two numbers. Their sum has to be 110. Now, this is what I'm talking about. Here's my numbers. Say I had 10 and 100 and 100. What's their sum? Their sum is 110, right? When I add them, sum means add them, right? What would their product be? What would their product be when I multiply them? This is 100. Multiply the ones, carry your zeros. Your product is going to be 1,000, right? I'm just giving you like a scenario here. You want them to sum up to 100, 110. We want to see what does a product at a maximum mean to me? So I'm just giving you some numbers to throw out. So what if my number was 20? What would y be? Would be what? It has to add up to 110. 90. Okay? So they add up to 110. What's my product? 1,800. So did my product increase? Yes. Right. So my goal is to find two numbers that when I add them up, I get 110. But this number will be the highest number I can get. Now I can stand here and try this for a long time, or we can make formulas out of this. So the rule is whenever you maximize or minimize, this is going into your y1. That's what's going into our calculator. That's what's going to make this parabola. Is this parabola going to open up or down? Down, because I want a maximum, right? I want a maximum, so it's got to go like this. I want two positive real numbers. So what quadrant am I going to be in? First. Good. All right, so let's keep that in mind. So we have two formulas. One is the sum. One is my sum, so as my board comes back on. All right, so your sum is, here we go, 110. 110. So how do I represent the sum of two numbers? X plus y equals 110. My product is its maximum. How do I represent the product of two numbers? X times y. So my product is x times y. My product is what's going into my y1. Now, your attention for just 1 second. This y and this y are not the same y. This y represents your product. That's what's going in your y1. This y is one of your numbers. So I labeled this as y1. This is your product. When we come out of this, your y1 from your calculator will be your product. This is our product right here. Now, if I go to my calculator, I can't put x times y in my calculator, right? I can only put x. So we're going to come back here and solve for y. So that I could take this information and substitute it into here. So I'm going to solve for y. So subtract x. I'm going to replace this y with 110 minus x. You can leave it like this when we put it in your calculator, but I want you to notice What is x times negative x? Negative x squared. There's where your parabola is turning. Plus 110x. See your parabola turning? It's opening down. Now, we're going to put this in your calculator. We have a little bit of work to do in your calculator, though. When you go plug it in your y1, David said they're both positives. They're in quadrant 1. So we have to set our table to give us only quadrant 1. What do I have to change in my table to give us quadrant 1? The window. I got to go to my window. And what am I going to change to get quadrant 1?
Negatives.
The negatives. I got to make my minimums be what? Positives or 0. So we're going to make your minimums start at 0. Clear out whatever's in here. Now, we're going to put your equation in here. X times 110 minus x. And just graph it for the heck of it. Just graph it. So we don't see it. So we're going to start here. We're going to start at your window. We said the x min has to be 0. And the y min has to be 0. Because we're in quadrant 1, we're not having any negatives. So y min is going to be 0, and x min is going to be 0. So we're in quadrant 1. We can't see it turn right now. So we're going to look at your table. We're going to go to your table. And we're going to come down to the zeros. And we're going to look a little bit. When we do a maximum, what happens to our y? It's increasing, 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 reaches a point, and then what? Decreases, decreases. So I want to look for my y to increase, 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 and then I want to see it decrease. It's still increasing, right? Still increasing. Look at my y's. My y's are still increasing. Still increasing. I'm just scrolling down. See the y increasing? Still going. What? I started to decrease.
When?
Somewhere over here. It doesn't matter exactly. So I'm just going to round this. I'm going to say, I noticed that at 59 it was decreasing. I'm going to say 60. I just need to chart my x. So halfway through, I'm going to say it was 60. Halfway through, I was at x is 60. And my y was about 3,000 or so, right? So now, on my window, halfway through, I was at 60. So double this. Because I'm only went halfway through. So about 120. Okay? On my y max, it's still about 3,000. Okay, I'll just make it like 3,500. I don't remember where it was exactly. So we'll just make it 3,500. No, it's not. No, it's not. You can't get wrong on this. And I'll explain how to get this even easier in a second. Even easier. When you have a maximum, we'll hit your maximum right away. But you've got to be able to see your parabola turn. If you can't see your parabola turn, you can't do your min or max on it. So now do a maximum on this. I want to see that point. I missed it in my table. I didn't find it in my table. Somewhere in here, it did. Look where it turned exactly. See it? But I didn't quite spot it. So I'm going to my graph, and I'm going to do a maximum. Do a number 4. Scoot to the left. Scoot to the right. Alright? And there's my maximum. At 55, 325. And that was in my table. I just didn't quite see it. So my maximum point here is at 55, 3,025. This is my y1. This is my product. This is my x. See what that y gives me? Now, you needed to know two numbers. You know one of them. You know the x. So you come back over here with your x, and you plug it in. If x is 55, what's my y? Y is 110 minus 55. Oh, my y is also 55. So if I want to maximize my product, which makes a turn, I want the highest point, I could do this for a long time until I get that. It'll take me a very long time. Or I can use a formula. Whatever I'm maximizing or minimizing is going in here. Now, if you took this guy and you proved it out, and we said, okay, this is equal to my y, and you completed the square. Just hang with me for one more minute. Here's my x's. You completed the square. You took this out. You added something, and we had nothing there. Then you subtracted it. Here's my x. Half of this is 55, so I've got minus 55 squared. When I square it, there's my 325. And I have a negative of 325. Look at my vertex. 55, 325. There's my negative 1. That tells me I'm turning down. You see it? All right. Now, you're going to apply this to this side. Hang on for 1 second. You're going to do this one. This one's a maximum. You're only doing 1 through 4. But when you do this one, guys, when your sum is a minimum, this one has to be your y1. This is your sum. Okay? And your minimum is going to open like this. So try 2 through 4. You should get number 4.
Do you have a worksheet this Friday or classroom?
Yeah, go in the